Hi, I'm your green instructor. Let's get started with Lecture 2 in Dimensional Analysis. Lecture 2 is on same object division. The objectives: we want to know what vertical reduction is, know how to vertically reduce fractions, know what same object division is. Vertical reduction is a concept that helps us to understand dimensional analysis. It is a concept that I borrowed from a great Algebra 1 book by Sterling in 2010. Basically, vertical reduction is the process of dividing the numerator and the denominator of a fraction by the same number. It is what we do when we simplify fractions. So vertical reduction makes things smaller. As we can see in the little picture, let's look at a vertical reduction example. Let's use vertical reduction to simplify the following fraction or ratio, 8 divided by 10. Notice that 8 and 10 are both divisible by 2. So we divide 8 by 2 and we get 4. And we can divide 10 by 2 and get 5. And so 8/10 or 8 divided by 10 is equal to 4/5 right here. So why would we want to go through the trouble of reducing a fraction and making the number smaller? Okay, because for some people, it may be easier to visualize 4 parts out of 5 rather than 8 parts out of 10. And also, it's best practice to reduce numbers to the smallest possible numbers when we're performing math. So 4 is smaller than 8, 5 is smaller than 10, but this fraction here, 4/5, is equivalent to 8/10. Now, pay close attention to this example because it's the start of what we really want to get to understand the mechanics of dimensional analysis. Use vertical reduction to simplify the following fraction, 5 divided by 5. Yeah, this is a fraction that has the same numerator as denominator. Now, we know that 5 is divisible by 5 because any number is divisible by itself. Therefore, when we divide the numerator by 5, we get 1. When we divide the denominator by 5, we get 1. So the fraction 5 divided by 5 is equal to 1 divided by 1, which is equal to 1. Anything divided by 1 is equal to itself. It is best practice not to leave an answer with 1 as a denominator. Whenever you see a number written down, you can visualize the number as itself divided by 1, but again, do not leave answers with 1 as the denominator. So if I had the number 15 divided by 1 in my answer, And I don't like to see that as a final answer. And as a matter of fact, I and a student got into a pretty good debate about this because that particular student um, left his answer as a fraction, and I had told the class previously that we don't leave our answers with a 1 in the denominator. So 15 divided by 1 is the same thing as 15. Okay, let me give you some insight into why 5 divided by 5 is equal to 1. If we remember that division is just grouping, and in my 5th grade lectures on 5th grade math, division is one of the main components of the book and the lectures, because the 5th grade is, in my opinion, a dividing point between students that are going to succeed in math and those that are not going to succeed. And the main problem is division. So if we remember from 5th grade math, hopefully your teacher taught you this, that division is just a grouping exercise. So we recognize that 5 divided by 5 is simply asking the following question. If I have 5 items, how many groups can I form if we put all 5 items in each group? The answer is 1. We can only make one group of 5 if we only have 5 objects. So let's just say I got 1, 2, 3, 4, 5 circles. And the question is, how many groups can I form if I put, how many groups of 5 can I form if I put all 5 items in a group? Well, because I only got 5 items, if I put all of these into a group, I don't have any more left. And I have just one group. So 5 divided by 5 is equal to 1. Okay, same object division is a concept that I created. And the key point is that any number divided by itself is equal to 1. And let us extend this and say that any object, a number, a symbol, a word, an animal, a book, whatever, divided by itself is equal to 1. Hence, same object division. So we're going to call this the same object division rule. And of course, we can never divide by 0. So 0 is an exception. An extension of the same object division rule says that if I have any number of objects, I can only form one group if I put all the objects into the group. For example, if I have 5 items like in the previous slide and put all 5 items into a group, I can only make one group. Anything divided by itself is equal to 1 based on same object division. So that's why all of the following ratios are equal to 1. 69 divided by 69 is equal to 1. A million divided by a million is also the same thing as 1 million divided by 1 million. That's equal to 1. B divided by B is equal to 1. A fish divided by a fish is equal to 1. Now, it may sound a little bit silly or seem a little bit silly here, but basically I'm showing you that when I have the same unit, say fish is a unit in the numerator and fish is a unit in the denominator, the same units will cancel each other out. And that's basically one of the underlying fundamental mechanics that we're going to use in dimensional analysis. 1 pound divided by 1 pound is equal to 1. 1/4 divided by 1/4 is equal to 1. 1/5 greater divided by 1/5 greater is equal to 1. Let me share with you something that you probably don't know at this point. Whenever we see a number or a variable written down, a variable is just a symbol that represents an unknown amount. Let's say that I have the variable x. X represents some unknown amount. And once you get to the great course called algebra, you're going to study variables. Now, you don't see it, but it is implied that there is a 1 in front of the x. So 1 times anything is equal to that anything. So 1x is equal to x. That's why up here we said that million is equal to 1 million. Million is equal to 1 million. Remember the same object division rule. If we can remember that rule, which tells us that any object divided by itself is equal to 1, then we are ready to start with dimensional analysis. Now, earlier, we saw that we could form a ratio between any two unlike objects. Example 2 showed that we can form a ratio with the same object as well. And the ratio is special because its value always equal to 1. Yes, an object is always equal to itself. Summary: vertical reduction is the process of dividing the numerator and the denominator of a fraction by the same number. It is what we do when we simplify fractions. The same object division rule says that any object divided by itself is equal to 1.